Hi guys, Sajjad Hussain again with a new video. In this video I am going to take another example from PCA notes. As you can see, this is PCA notes on ACI 31808. So this time I am going to take this example 11.2. Design a cylindrical column with slenderness effect for column in a sway frame. If you remember before, in my last video, the example which I considered, it was 11.1, and that was a non-sway frame. But this time this is a sway frame. In sway frame, as you can see below, no shear wall. So the moment resistance, this is a moment resistance frame, but there is no shear wall. This is a 12-story building. As you can see, this is the elevation, and here is the plan, and the parameters are given. Again, here the wind load is computed according to ASC 7, but no information is given about wind load or seismic. So what we will do here, because of this sway condition, we will take some value for wind, and we will consider this as a seismic category C structure. We will take some values for seismic category C design, and we will design this structure, and we will see what the results are. So let us start. Let me put the screens side by side, windows, both the windows side by side, so that I can easily take the values. So you can see the parameters given here are: the concrete is 6000 psi for column and the bottom 2 stories, and elsewhere the concrete is 4000 psi. Reinforcement is 60 ksi. Beams are 24 by 20 inch. Exterior columns are 22 by 22. Interior columns are 24 by 24 inch. Superimposed dead load is 30 pound per square foot. Roof life load is 30 pound per square foot. Floor life load is 50 pound per square foot. So let us model. As you can see, there are 5 bays in X direction, and they are all 24 feet apart. In Z direction, there are 3 bays, they are also 24 feet apart. So geometry is pretty simple. Let us start. New model. Our default units, kip and feet, right? So we will go for 3D frame system. It's not an open frame. Beam slab building, because here the slab is 7 inch. So we have to consider the slab also. Number of stories are 12. Story height is also 12. Number of bays in X direction 5, they are at 24 feet. Number of bays in Y, they are 3, 24 again. Let's distribute 3 by 3. Okay, here we can edit spacing. Ground floor is 15, so let it be 15. Okay. Now we have to assign the properties of beams and columns. Let's add a beam. New property, concrete. Beams are depth is 24, that means 2 feet, and 20 inch. Material 4000. It is a beam. Okay, the reinforcement is 615 grade 60. That is correct. Sorry. Let us give a name beam. Let's use the capital beams. So for columns, let us add one more property. Okay. The interior columns are 24 by 24, exterior columns are 22 by 22. Let's say these are exterior columns. Columns exterior 22 inch by 22 inch. All 4000 psi. They are columns. Okay. 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 Area. Okay, let's add the area section, that's the slab. These are the slab. It's only 7 inch thick. So these are 7 inches. 7 inches. 4000. Okay. Okay. Constraints are okay. So we have defined beams, exterior columns. Later on we will modify the columns and we will define interior columns and the properties also, material properties also. So we have defined all these things. Let's say okay. Fine. We can select all these nodes and assign, joint, restraint. Let's say these are all fixed. Let us save the file. Example 11.2. So we have to modify column properties. Let us define material first also. Add new material. We have to add concrete. 6000. Okay. Fine. Let us define sections, frame sections. Add new property, concrete. Let us say these are columns, interior, and interior are 2 feet by 2 feet. Okay, these are columns. Fine. Let it be 3D. Let's change over here. Now this is the exterior face. Let's move interior. Let us assign interior columns as our interior columns. Select interior columns. One more. Assign frame section. These are interior columns. Okay. Let us save. One more frame. Again we will do the same thing. We will select all interior columns and we will assign interior. So we have defined the interior columns as revised sections. Let us save the model. Now they say 6000 psi for column in the bottom 2 stories. So let us select only bottom 2 stories. All these columns, assign frame, material property, close. Assign frame, frame section. It will take little time. So frame. No, we are not going to define property modifier. Anyway, for the time being, let us leave as it is. Let us proceed. Clear the selection. Save the model. Now we have to define all the loads. So first, let us define the loads. Load pattern, dead load. Okay. Then we have to define superimposed dead load. This is super dead. Then we have to define live Then we have to define roof. Let's select the roof live load. Then we have to define wind. Let us define wind. Let's define wind as ASC 705. Add. Let's modify. We will define the rigid diaphragms later on. All cases fine. So instead of 70, let's take a value of 110 miles per hour. Rest are fine. Okay. Then we will define earthquake in X direction. So it will be quick. Let's select IBC 2009. Add. Let us modify this lateral load. It should be in global X direction. Okay, this is fine. This will be 0.16 and 9 as per AC7. It's frame building 8, 3 and 5.5. This is correct. And for seismic category C, in one of my last example, it was 0.949. Let me check. It was 949. It was site class D, sorry, 424 and 0.094. I was mistaken. 0.424 and 0.094. Site class was taken as D. Okay. Similarly, we can add earthquake in Y. This will be in Y. 0.424, 0.094, D. Okay. So we have defined load patterns. Now these load cases are already generated. These are all linear static. Later on I will show how to define the load cases for P delta analysis, because P delta analysis is a non-linear geometric non-linear analysis. So later on I will show you how to do that. For seismic load, let us define the mass source. So the dead load should be added. Superimposed dead load should be added. And portion of live load, say 0.25 live load we can add for the roof. Yeah, we can take that one also. So these are the loads which should be considered as masses for the seismic loads. Okay. Okay. Dead load is okay, fine. The current mass source includes both. Let's see. No, that's correct. Okay. Now let us assign the forces, the loads. Let us assign the superimposed dead load. The superimposed dead load is 30 pound per square feet. Let us select all slabs. Assign area load. We can convert this to pound per foot. Global direction, and it should be superimposed dead load, that is 30 pound per square feet. Let us add to the existing and replace the same thing. Then we have to add floor load. Select previous, but then we can unselect the roof elements so that we can select the live load for floors, that is the floor load. Assign area load uniform. Now this time we have to select live load. Floor live load is 50 pound per square feet. Okay. Now we have to select this time the roof elements. Assign area load uniform, and this time it is roof. That is 30. Okay. Let us see. Now we have to define constraints. Select all. Let us assign constraints. These are the diaphragms. Add new in Z axis, and we should assign for every level. Okay. Apply. So let's see, sign joints constraints, right? Let's see later on. So far we have not defined any load combination. Let's see if we run what happens. Okay. Okay, no issues. Okay, we will delete. Assign join constraints. Why? Just try constraint one more. Assign join constraints. Define join constraints. Diaphragm. This is delete. New constraint. Let it be diaphragm 1. Okay. Let us analyze. Okay. Let us see the deformed shape of wind. Apply. Okay, this is the next direction. Display deformed shape wind 2. This is perpendicular. Oh, something wrong with the definition of constraints. Assign join constraints. Diaphragm new constraints. Okay, cancel. Okay, so let's define manually. So let us select this, assign join constraint. Let us delete, yes. Diaphragm new, diaphragm 1, okay. Okay. Apply. Let us select the second one. Should have been assign joint constraints, define new constraint, diaphragm, add new constraint, global, okay, apply. So this is number 3, assign constraint, it's a little bit hectic. Okay. One more. Assign joint constraints. These are diaphragms. Add new constraint. 4. Okay. Apply. No problem. Assign joint constraint, define new constraint, diaphragm, add new constraint, yes, okay, apply, close, one more up, select the nodes. Now assign joint constraint, we have to define new diaphragm, okay, apply. So one more, assign joint constraint, define new constraint, diaphragm, add new, okay, okay, apply, one more, assign joint constraint, diaphragm, add new, okay, okay, let's apply. So one more, let us assign joint constraint, diaphragm, new, okay, okay, apply, fine. Assign joint constraint, diaphragm, new constraint, okay, apply, one up, level up, assign joint constraint, diaphragm, new, okay, okay, apply, fine, one more up. So that is the last one, thanks God. Assign joint constraint, diaphragm, new constraint, okay, okay, apply. Let us save the file. Let us analyze. Okay. Now analysis option, we should select multi-thread. Okay. Okay. Let's save, analyze, run. So let us see our deformed shapes. Earthquake X, apply. Okay. No, there's something wrong. No. Now let's that's okay. Define constraint again. Cancel, close, select all, assign joint constraint, diaphragm, add new, diaphragm number 1, each one, okay, okay, apply, fine. Let us analyze now. That's correct. We were mistaken. That's correct animation. Yes. So this is earthquake X. Let's see. Earthquake Y. Let's see the animation. This is earthquake Y. This is correct. Now let's see the wind. Let's see the wind load cases. Maybe this displacement is small. We have defined the wind loads, all the wind loads, extent of rigid diaphragm, that is correct. Okay, analyze, let us analyze once more. Anyway, let's define the load combinations. Define for concrete. Okay, save. Let us analyze. Now so far we have not defined the P delta load cases. I'll show you how to define the P delta load cases once the run is done. We can design our concrete 318 seismic category, it's C, SDS is 0.424. okay, all the combinations are selected. Let's start the design. It will take little time. So the design is going to be finished very soon. So let's see, is there any member fields? Design, concrete, verify analysis versus design sections. Okay, design, concrete, 8 concrete frame field. So yes, we want to select them. So these are the columns here, here, they are overstressed. Since we are not designing the columns now, so what we are going to do, because of the seismic load which I have included, now I want to show you how to define the geometric nonlinearity, that means the P delta effect. So what we have to do to perform a P delta analysis, we have to define the load combinations and we have to convert those load combinations to non-linear cases. Yes, so we have to select all. Instead of going one by one, let us select all. Okay, okay. Now these load cases, those load combinations which are selected, they will appear in load cases. So here all these are selected as load cases, and if we see what are the load combinations, so we will see here, for example, the dead load and live load, the combination is there and it has to perform a non-linear analysis and it has to perform a P delta analysis. So this is the way we have to define the P delta, or we have to define the P delta analysis in SAP. Okay, okay, so let us run one more time. Yes, we want to run. Maybe it will take little more time because lot of non-linear load cases are also defined. Because I do not edit my videos, so that's why for constraint definition there is some problem. I will investigate, and in the next video I will try to find the solution why there is a problem. But anyway, the point is you have to define the constraint and you have to select the limits of load definition for wind and seismic for all these constraints. And once you define the constraint properly for all the floor levels should have constraint levels, so then what we can do, we can perform the analysis and we can perform the non-linear P delta analysis. In our linear analysis, we observed that there were only 4 columns overstressed. That's not an issue. Let's see if we add the P delta, then what will be the impact? There will be some more columns overstressed or there will be okay. It's a lot of cases, that's why it's going to take a little more time. But for geometric nonlinearity, actually, if you go to ASC 7 and chapter 12, paragraph 8, then there is a condition, and you have to see that condition to perform P delta analysis. That governs whether a P delta analysis is needed or not. If you are satisfying that condition, that you may not need a P delta analysis, but if it is required to perform a P delta analysis as per chapter 12, as per paragraph 12.8 of ASC 7, then you have to perform P delta analysis. But what I assumed, that the P delta analysis is required and we are going to perform P delta analysis. So that's why I consider to perform the P delta analysis. And that's why I showed here how to perform P delta analysis, how to define basically a load case for a P delta analysis. So the analysis is complete. Let us design. Let's see the combinations. All the combinations are there, non-linear. Okay, fine. So it's going to take some more time. Maybe in next video, when I will design a truly seismic category C structure or D structure, where you have to check all the details, then at that moment I will explain more how to define the P delta load cases, what is the impact, and if a building lies in seismic category C or D or E or F, then what should be the details required and how SAP will give the results. So let's see, is there anything? Now the same result. Yeah. So that means this overstressing is there. Some columns, 8 columns are overstressed. Maybe a careful definition of columns, etc., since the P delta was not considered over there, so that's why these are overstressed. Rest we can check, the columns are okay, so they are within the limits. So basically this was my intention, to show you how to define the wind and seismic loads, and how to define the P delta analysis, how to define the load cases for P delta analysis. So hopefully it will make you very clear. Thank you very much. Bye.